Welcome viewers, in this video we will see the speed control of universal motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, speed control of universal motor. The name universal motor implies that it can be operated on both AC as well as DC supply. That's why it is called a universal motor. The main application of universal motor is the high speed applications where we need a high speed that we can use. For example, food and drink mixer and swing machines, portable drillers and vacuum cleaner. For that purpose we are using this universal motor where we are need a high speed. In that the speed control is important feature. Due to the application, the speed control is very important. So there are some methods available for a speed control purpose. Basically 3 methods are available. We'll see this one by one. The first one is the resistance method. We know that this universal motor having rotating part armature and fixed part field. Field and armature is available as usual like a DC motor. This is the rotating part armature. This is the field winding. So both are connected in series. So in resistance method, the resistor is connected. Variable resistor is connected in series with the field winding and armature. So by controlling the resistor, the current flowing through the motor will vary so that field flux produced by the field winding will vary so that speed of the motor is also varies. So by increasing or decreasing the resistance, we can increase or decrease the current, thereby increase and decrease the field winding flux, thereby the speed of the motor will increase or decrease. So as shown in the diagram, motor speed is controlled by connecting a variable resistance or in series with the motor. This method is employed for the motor used in swing machines. The amount of resistance in the circuit changed by means of foot pedal. So mainly this method is applicable in a swing machine. Swing machine, the speed is controlled using the foot pedal. By slowly pressing the foot pedal, the resistance will vary so that speed of the machine also varies. So it is one of the simplest method commonly used in the swing machines. Now we'll go to the next method. Next one is the tapping field method. The field winding, the tappings are connected. So this is a rotating part armature. The 2 poles are available. One pole is fixed. This is commonly connected. In pole 2 is permanently connected. The pole 1, there are 3 tappings are there. So by changing the tapping position, the field winding, the amount of field connected to the motor will vary. So that the field flux produced also vary. We know that flux and speed is inversely proportional. So the flux increases, speed will decrease. Flux decreases, speed will increase. So based on that, we are having 3 tappings are available. So one pole is permanently connected, another pole is connected with the tapping. See this 3 tappings given low, medium, high. So in the position 1, low means the entire field is connected. If the field is connected means field flux will increase. If the flux increase, the speed will decrease. So that is called a low. And the third one, high. See that it is connected. If the switch is connected here means the pole 1 is not connected. It is directly goes to pole 2. Pole 1 is disconnected. So the field flux will not produce. Flux will be less. So the speed will increase. So that is called a high. The high speed. Right. So while connecting low, the entire pole 1 is connected. So the field flux will be produced. More flux will be produced. If more flux is there means the speed is reduced. Speed is decreased. Speed and flux is inversely proportional. When the flux increases, speed will decreases. So that's called a low. When it is connected in high, this field is not connected. Only pole 2 is connected. So only pole 2 means the flux produced by the pole is decreases. So the speed will increases. So that it is high. So in between it is connected means around 50% is connected. So we'll get the medium speed. So here another, based on that there are 2 methods available. One is this method, connecting the pole with the tapping. And another method is we can connect the resistor wire also. wire is wounded over the fixed pole. Over that we can have a resistor wire also we can make it. So one is the pole is connected with the tappings. Another method, in pole we can wind over the resistance wire. That is another method. So in this method, a field pole is tapped at the various points and speed is controlled by varying the field strength as shown in the diagram. Field strength means if the field is connected completely, more flux produces, speed decreases. If the field is not connected, less flux will be produced, so more speed will be there. So for this purpose, we can have two methods. Either of the following two arrangement may be used. First one is the field pole is wound in various sections with a different size of wire and taps brought from the each section, right? So we can have a various section, different size and wire and taps. Different size of wire and tappings are taken, what we discussed in the diagram. Another method is nichrome resistant wire is wound over the one fixed pole and taps are brought out from the wire. So this is what we discussed in the diagram. Tappings are taken, different size of wire. In addition, we can use the nichrome resistance wire also. In that also we can control the current flowing through the field winding. So the third method is centrifugal mechanism. We know that centrifugal mechanism means if the speed is more, automatically the switch will be disconnected. Right, see the centrifugal arrangement. So this is the armature, rotating part and the field winding. So here we have the centrifugal mechanism. This is a centrifugal switch. So the external lever is there. By using the lever, we can open or close the switch. Not only centrifugal mechanism, it can be controlled in the external also. So one side the capacitor is connected, another side resistor is connected. This capacitor, during high speed, any sparking is there, that will be reduced by the capacitor. This resistor, if the switch is open, the resistor is connected to the motor, so that the current flowing through the motor is controlled, this decreases. If the switch is closed, what happens? The resistor is disconnected, bypassed. The current is directly flows to the motor, so more current will flow. So if the speed is more, the case 1, first case, if the motor is rotating at very high speed, by using external lever, we can close the switch. So that what happens, the current will flow through the resistor. So the resistor will allow only few current. Resistor will restrict the flow of current. So the current flowing through the motor is decreased, so that the speed will decrease. Case 1, motor rotating high speed, by using external lever, the switch is closed. So now the current will flow through the resistor, so the current is decreases, so that we can reduce the speed of the motor. Case 2, suppose the motor is rotating in a slow speed, then we can open this, we can close this. We can close this switch. If it is closed, what happens? Directly current will flow through the field winding. So more current will flow, so the motor speed will increases. Right. So operating from external lever, we can control the speed of the motor. Right. If the speed of the motor is high, then we are opening this centrifugal switch, so that current will flow through the resistor. Current is decreased. If the motor is rotating slowly, then we are closing this centrifugal switch. At that time, the current is directly flows, so more current will flow and the motor speed will increases. Now we'll see this detail. Universal motor, particularly those used for home food and drink mixer, have a number of speed. So the drink mixing and food mixing, we need a high speed is there and a different level of speed. Initially we need less speed, thereby we need a more speed. So in that purpose we can use. So the external lever is there. So by using that we can close or open the switch. Selection is made by the centrifugal device located inside the motor and connect as shown in the diagram. So the centrifugal switch can be closed or open according to our requirement. Now we'll see the further detail. The switch is adjustable by means of external lever. External lever is available. So we'll see the first case. If the motor speed rises above the set speed set by the lever, then the centrifugal device open two contacts. So the centrifugal switch is operated by the settings, not manually. Right? We can set the speed in the centrifugal device. So it will check the speed of the motor. If it is above the set speed, then this centrifugal device open two contact and insert the resistor R in the circuit, which cause the motor speed to decrease. Right? It's not the centrifugal switch, the external lever is there that can be used to control the centrifugal switch manually, as well as it can be set. Speed is set by the operator, so that it will check the speed. If it is more, automatically it will open the contact and insert the resistor, so that current flow will decrease, so the motor speed also decreases. Right. In the second case, when the motor runs slow, the two contact closes and short circuit the resistance. If the resistor short circuited, means the current will directly flow to the field winding, so that motor speed will rise. This process is repeated so rapidly that variation in the speed are not noticeable. If the speed variation is there, then it will make a connect. It will connect or disconnect the centrifugal switch until if it is there is no variation, it will go as usual. The resistance R is connected across the governor point as shown in the diagram, that we'll discuss in the diagram. A capacitor C is used across the contact point in order to reduce the sparking produced due to opening and closing of the point. Moreover, it prevents the pitting of contacts. Right. So in this method, centrifugal mechanism is used. With that, we have resistor and capacitor is connected. Capacitor reduce the sparking. This resistor used to control the flow of current to the field winding. If the speed is more, the switch is open. That is the mechanism set. The speed is set by the speed is set by the. We can set the speed accordingly. This centrifugal mechanism will open or close the switch. If the speed is high, it will open the centrifugal switch and connect the resistor, so that current flow will be controlled, thereby speed is controlled. If the speed is slow, it will connect the contact, so the current is flowing directly to the field winding without resistor. So the current flow will increase and the speed also increases. Right. So if any variation in the speed is this mechanism will continuously check the speed of the motor until it is rotating in a set speed. Otherwise, it will either open or close the switch to maintain the constant speed. So in this video, we discuss about the speed control of universal motor. There are three methods. One is resistor, simple method, connecting the resistor to control the flow of current, thereby control the speed. Then tapping of the field winding. Third one is centrifugal switch. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination. Welcome viewers. In this video, we will see the construction and operation of universal motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, universal motor. The name itself, the universal motor, it can be operated on AC as well as DC. That's why it is called a universal motor. The important feature of this motor is high speed, having mostly only two poles are there, so the speed is very high. So the application where we need a high speed, we can use this universal motor. Normally the swing machine, vacuum cleaner, food and drink mixer, then we are using this universal motor. Now we'll see the detail. A universal motor is one which can operate on AC or DC supply at approximately same speed and output. So we can operate on AC as well as DC supply. In that we got the same speed and output. So that is called a universal motor. Its construction is very similar to that of AC series motor. Armature and field is connected in series like a AC series motor. Now we'll see the types of the universal motor. There are two types of universal motor available. One is concentrated pole non-compensated type, that is used for low power rating. Distributed field compensated type, that can be used for high power rating. Now we'll see that what is meant by concentrated and non-concentrated and distributed compensated. We'll see the detail one by one. First we'll see the non-compensated universal motor, cross section of non-compensated universal motor. So it is like a DC series motor or AC series motor. This is armature, brushes are there. This is a field winding. There are two poles available. This winding is available in the first pole, then it goes to armature, then go to the next pole. So it's a series motor. Field and armatures are connected in series. We can operate with either AC or DC. So armature winding, field winding. Now we'll see what is meant by the compensated or non-compensated type. The non-compensated motor has two salient pole and it is like a two pole DC motor. Salient pole, this salient means projected, except that whole of its magnetic path is laminated. Right? Salient pole, field windings are there, then it is magnetic path is laminated. Armature is wound type and similar to DC motor. Armature is normal DC motor. It is similar to the DC motor. Now we'll see the further detail. It has a laminated core having straight or skewed slots and a commutator to which the leads of the armature winding is connected. Right? It's a laminated core. Either skewed slot or straight is there and a commutator to which the armature winding is connected. Now we'll see the another type. So both the diagrams are available, compensated and non-compensated type. Non-compensated type, compensated type. Compensated type means the compensating winding is available in addition. So in the non-compensated type, normal supply is given, armature and main field, these are connected in series. Rotating part and stationary part, armature and main field winding connected in series. Here in addition we have compensating winding is available. We'll see why we are using the compensating winding and what is the purpose. The distributed field compensated type motor has a stator core very similar to that of a split phase motor and a wound armature similar to that of DC motor. Right? So the stator core having split phase. Split phase means having two poles, two phases. In a induction motor we have split phase is there. Because in single phase we cannot create the rotating magnetic field. Minimum we need two windings are needed. So that is splitted. The winding is splitted. And another condition is the current flowing through this splitted winding have the displacement approximately 90 degree. Then only the rotating magnetic field is produced. So like that here also we have split phase motor. We have main winding and compensating winding. Two windings are available. Now we'll see the working of this motor. This motor develops unidirectional torque whether they are operate on DC or AC. It's a unidirectional torque is produced for both AC as well as DC. It works on same principle as the DC motor. Now we'll see the diagram. So this refer this diagram A. So this left hand side the N pole is created, right hand side S pole is created. So this is during positive half cycle of the AC supply. When AC supply is given, what happens? N pole will be created in left hand side, S pole will be created in right hand side. The current is flowing through N pole, then armature, then S pole from left to right. While during the positive half cycle of the AC supply, this is the position N pole and S pole. Similarly, during negative half cycle, what will happen? We'll see the diagram B. This diagram B refers negative half cycle. Now left hand side S pole is created. Right hand side N pole is created. Current is flowing in reverse direction from right to left. current start flowing from N pole, then armature, then it will goes to the S pole, just opposite of the previous diagram. So this is the position of the current direction as well as the pole position during positive off cycle and negative off cycle of the AC supply. Now we'll see the further detail. For DC supply, if both field and armature current reverse at the same time, unidirectional torque is produced. So if it is DC supply, if you reverse the field winding and armature winding, the direction will be reversed, but we will get the unidirectional torque. That is the advantage of this motor. Whether it is reversed or forwarded, always we are getting the unidirectional torque. Now we'll see what happened in the AC, what we discussed in the diagram. Similarly, for an AC supply in positive off cycle, that diagram A, left side is N pole and right side is S pole. Armature current flow from N pole to S pole. What we discussed in the diagram A, the description is given. Similarly, negative off cycle. What will happen during the negative off cycle? In negative off cycle, diagram B, field polarity is automatically interchanged. So the direction of current also interchange. That is, the left hand side S pole, right hand side N pole. The current flow from N pole to S pole. Right. The torque is directly proportional to pi into Ia. We know that series motor, it is proportional to flux as well as Ia, because field and armature are connected in series. Suppose if pi is reversed, Ia also reversed. So what will happen? T is directly proportional to minus pi into minus A. So negative available 2 times, so it becomes pi A. So that what is the meaning? Therefore, torque is unidirectional for AC supply also. So, with the DC supply we are getting the unidirectional torque. For AC supply also we are getting the unidirectional torque. Now we'll see the speed torque characteristics of a universal motor. So when the speed torque characteristics is available here, we know that it is very similar to AC series motor or DC series motor. It is inversely proportional. Torque and speed is inversely proportional. X-axis we have torque is available. Y-axis speed is given, right? So it is inversely proportional and it is decreases in a parabolic manner. So in case of DC, this is the characteristics. So it is not reaching the zero. Speed is not reaching the zero value. In case of alternating current, it is keep on decreases. The speed is, the torque is keep on decreases and reaches this maximum value. At the time the speed is zero, right? But in the DC current, the speed and torque both are available. This a particular value is available, is not reaching the zero value. That is the difference between this alternating current and DC direct current. The speed of a universal motor varies like a DC series motor, low at full load and high at no load speed, right? So it is about 2000 RPM in cases. In fact, on no load the speed is limited only by its own friction and windage load, right? During no load also it is rotating in a high speed, right? So this characteristics is very similar, inversely proportional, but we have the difference in DC and AC, right? The speed here, some speed is available in case of DC. In case of AC, the speed is zero, and the torque, while the speed decreases slowly, the torque is increases also slowly, right? It is inversely proportional. The above diagram shows typical torque characteristics of a universal motor both for DC and AC supply. Universally, gear trains are used to reduce the actual load speed to proper value, right? So further we can use the gear system to control the speed from the actual speed to the proper value. According to the application, we can use the gear trains. Then applications. What are the applications of this universal motor? Universal motors are used in vacuum cleaners where we need a high speed, where the actual speed is the load speed. And other application where the motor is reduced by the gear trains are drink and food mixers. Here we are using the full load. actual speed and load speed is equal. Here using the gear train, the speed is reduces, and we are using in drink and food mixture, portable drill, domestic swing machine, etc. These are all the applications. Now we'll see the reversal of rotation, how to reverse the speed of the universal motor in case of both AC as well as DC. The reversal, the concentrated type and non-concentrated type. Whether AC or DC, same thing. In concentrated type or salient pole type, the universal motor may be reversed by reversing the flow of current through either armature or field winding. So this is the normal procedure. Either armature or field winding, if you reverse, the speed will be reversed. This is the usual method is interchange the leads of the brush holders. Right? The brush holder leads are interchanged so that the speed will be reversed. This is a normal procedure. In case of distributed field compensated type, universal motor may be reversed by interchanging either armature or field leads and shifting the brushes against the direction of the in which the motor will rotates. So in previous case, this interchanging the brush holder, now shifting, here also shifting the brushes, same thing, is very similar to the previous case. The extent of brush shifting usually amount to the several commutator bars. With commutator, using commutator bar, the brush shifting will be done. So the reversal of motor in both concentrated and non-concentrated type, either armature or field windings are reversed. So that can be done by interchanging the leads of the brush holder. So in this video we discuss what is meant by universal motor, what are the types are available, what is the operating principle, then followed by the speed torque characteristics, application and speed of reversal. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.